Okay, so at this point, when they talk about a Pythagorean, I say Pythagorean identity, you would have seen a few of these. One of them, the one in particular for this problem, is that sine squared theta plus cosine squared theta equals 1. And keep in mind that we can write this off to the side. Sine squared theta is a more abbreviated way of writing this. Okay, we just put the squared in between these two, but we're saying whatever sine theta is squared. Okay, so if we keep that in mind, and we're starting off with the information that sine theta is equal to radical 3 over 2, then in here we could replace our sine theta with radical 3 over 2, and we're squaring that. Okay, so again, sine squared theta is really sine theta squared. Okay, why don't I do that? Might as well. Keep it in line, yeah. So this is really saying this, okay? Until you get used to this notation, we can look at it like so. And if the sine of theta is equal to radical 3 over 2, we can put a radical 3 over 2 in here. And this is an equation that we can solve for cosine, okay? So when we square the fraction over here, we get 3 over 4 plus cosine theta squared equals 1. Subtract the 3/4 from both sides. We have cosine theta squared equals 1/4, right? Because 1 minus 3/4 is 4/4 minus 3/4. I hope that's obvious. So we get 1/4. And then as we continue solving this, to solve for cosine theta, we'd have to take the square root, okay? That leaves us with just cosine theta and the square root of 1/4, which is the square root of 1 over the square root of 4. Now, I'm going to make a comment here about the way this problem was set up, okay? There were no restrictions on what theta could be, and at this point in the game, you should have an understanding about the unit circle itself, okay? In fact, I'll draw this down here. But when it comes to the unit circle, okay, theta, forgive my unsharp lines here, but if the sine of theta is radical 3 over 2, and we associate the sine of an angle with its y coordinate, so when we started this problem with this fact, the y coordinate was positive. That means our angle theta has to be somewhere in the top half of the circle in quadrants 1 or 2, right? So say, for example, and maybe you know this, maybe you already knew, like, well, if the sine is radical 3 over 2, which means the y coordinate is radical 3 over 2, there's only one angle over here that's equal to that, and that's pi over 3, right? Maybe you didn't need any of this stuff, okay? But stay with me for a second. So this angle, pi over 3, has a sine value of radical 3 over 2. But so does, and we've talked about this symmetric nature of the unit circle, so does this angle over here that has the same reference angle, right? So this is 1 pi over 3. This is 120 degrees, or 2 pi over 3. So both pi over 3 and 2 pi over 3 have this sine value of radical 3 over 2. But the cosine of these two angles is different, because in quadrant 1, let me clean this up here. In quadrant 1, the y coordinate is positive radical 3 over 2, and the x coordinate is positive 1/2. In quadrant 2, the x coordinate is negative. So when I take this square root, I have to include positive and negative values because it didn't specify what quadrant I should be looking at, okay? So we're taking the square root of 1 over the square root of 4, which is 1/2. So technically speaking, without a restriction on the problem, the cosine value could be positive 1/2, or it could be negative 1/2. There's a lot of context clues that we have to look for in these problems. Without those clues, the answer could be two different values, okay? So are we talking now, a problem like this in a homework problem or in a math textbook, it might be followed up with a statement that says something like theta is between pi over 2 and pi. And if that's the case, then we would use only, then that means it's between here and here. Then we'd know we're talking about this angle, and we would only include the negative answer for this. Okay, so it's real subtle, some of the details that are in these problems. But you have to understand that in different quadrants of the coordinate plane of the unit circle, sign values are positive in places. Some places have negative sign values, and so vice versa with cosine and tangent. Okay, so just be aware of that when you're going through this stuff.